Hi semua. So we have actually did this experiment 1, the basic techniques in microscopy, virtually last week. And thanks to those who have already submitted the lab report for this particular experiment. And hopefully the rest of you can submit your lab report in the Google Classroom, okay, as soon as possible. And so just to guide you, okay, we will look at the things that we need to fill in, okay, for your lab report. Okay, firstly, it will be the title, very easy. This is something that you can get from the lab manual, and the same goes for the learning outcomes. Okay, you just check with the lab manual. I will go through this very quickly. Okay, and for the introduction, there will be some things that you can write. Okay, just follow the suggestion in the template, and for example, we can try to answer these questions. Okay, and actually we have already discussed these questions during the pre-lab session, okay, in which you should know that this will be the answers for all these questions, and we have already discussed these things, so no need for us to go through one by one. Okay, don't worry, I will just check your lab report just to make sure that you have tried answering all these things. The same goes for this labeling of the components of the microscope. Okay, I'm sure you can check the answers on your own by referring to the lab manual. Okay, I will now go to the procedure. Sometimes we need to write our own procedures, but sometimes you will be given parts of the steps, so you just need to fill in some blank spaces. For example, for exercise 1.1.1, you need to fill in these blank spaces over here. Just take note that whenever you write the procedure, you need to use this past tense in the passive form lah. Okay, in which if the step in the lab manual mention that you need to observe the prepared slide using the 4 times objective lens, and so in your lab report you just need to modify the statement a little bit into something like this. The prepared slide was observed using the 4 times objective lens. Okay, the same goes for step 2 and step 3. Okay, something like this. And the rest was already prepared for you, so you don't need to do anything. Okay. Okay, these are all inside the template. So we just go on with the result and observation. Okay, so for exercise 1.1.1, you need to draw the letter E. Okay, so I'm sure everybody can draw the letter E, and just make sure that the letter E is slightly bigger, and the letter E must be in inverted position. Okay, must be in the inverted position. And usually when we draw something, there must be a title for the drawing. Okay, so make sure that you put the title of the drawing. For example, the title will be the letter E. Okay, the letter E, that's all. Just a simple title. And state also the actual magnification under the title. Okay, so for this drawing, you just put the actual magnification is 40 times. Okay, 40x. Okay, and then for exercise 1.1.2 regarding the depth of field. Okay, the position of the threads through our naked eyes, or when we observe them under the microscope, okay, should be showing the same type of position. Okay, should be the same. So the one that is on top will always be on top, and the one that will be in the bottom will always be at the bottom lah. Okay, it will be the same. And we already have discussed that the depth of field will become smaller or becomes narrower. Okay, whenever the power of objective lens is increased. Okay, narrower or smaller. And then for exercise 1.1.3 concerning the field of view, you need to draw. Okay, you need to draw the image that you see of the transparent ruler under the 40 times magnification. So there should be a title also for the drawing, and also the actual magnification 40 times ataupun 40x. Okay, so based on your drawing, you should determine the diameter of the field of view. Okay, for the 4 times objective lens. Okay, or 4 times 10 magnification power. Okay, 40 times. This will depend on your observation actually. So example, this is just an example. Let's say I measure the diameter of the field of view for my through my observation, and the diameter will be 3.5 mm, and so this will be equal to 3.5, okay, times 10 to the power of 3 micrometer. Okay, micrometer. So this will be depends on your observation. So maybe you can write 3.5 the same, or maybe 4.0, or maybe something else. And this is all depends on your observation when you look through your own microscope. Okay, or when you make your observation virtually using the matrix microscope board. Okay, and the diameter of the field of view will be smaller when you increase the magnification power to 10 times 10, in which when you measure the diameter of the field of view, it will be about 1.5 millimeter. Okay, and in order to determine the diameter of the field of view for the 40 times objective lens or 40 times 10, it will be hard for you to measure directly. So you need to use this particular formula. Okay, in which the diameter of field of view at low magnification divide with the diameter of the field of view at high magnification equals to the high magnification power divided by low magnification power. Okay, so using this particular formula, you will be able to determine this particular value over here, because it will be very hard for you to measure directly using the transparent ruler. Okay, so this is how you get the 0.375 millimeter. This is how you calculate. Okay, 1.5 millimeter is the diameter of the field of view when you are using 10 times 10 magnification power. Okay, so using this particular formula, you will get the value of x, which is 0.375 millimeter. And for this particular part, you need to calculate the size of this particular cell. Okay, using the data that you have obtained for this one, 0.375. So this is all depends on your observation. Okay, so let's say the diameter of the field of view under 40 times objective lens is 0.375, and so this will be the length of the cell, okay, horizontally, and the length of the cell vertically will be this, and so the size of the cork cell will be 7.22 micrometer persegi, square. Okay, so this is how you can calculate the size of this particular cell. Okay, now let's proceed with exercise 1.2, which is very simple. You just fill in the table 1.1, in which if the magnification power of the objective lens is 4 times, while the magnification power of the ocular lens is 10 times, so the actual magnification will be 40 times. Okay, so this will be the complete answer for this particular table 1.1. Okay, very straightforward. And for exercise 1.3, actually this will be done later lah, if we have the chance to do this particular hands-on activity next semester, then you will be able to draw the image of the bacteria under the 1000 times magnification power. So for this particular lab report, it is okay if you don't have any drawing for this exercise 1.3. It's okay. Okay, now for the discussion. Normally this is what we will do for the discussion. So this is just the suggestion. Okay, suggestion that we normally do. And for this particular experiment 1, okay, this is what you can write for your discussion. For example, you can describe about the image seen under the microscope, in which you can mention that the image under the microscope will be larger and also inverted. Okay, larger and also inverted. Okay, and then you can also state the relationship between the depth of field, magnification power, and the image seen under the microscope. So you can write this particular statement in your discussion part. Okay, as the magnification power increases, the depth of field is smaller or narrower, and so less image can be focused vertically. Okay, and you can also state the formula for calculating the magnification power. Okay, what need to be written for this particular number 3? You just try to state the formula about this particular part, in which the actual magnification equals to the magnification power of the objective lens times the magnification power of the ocular lens. So you can write that particular formula in this part number 3. Okay, write somewhere here lah. Okay. And for number 4, state the objective lens that can use the oil immersion lens and state the function of the oil immersion. So it will be the 100 times. Okay, the objective lens that use the oil immersion will be the objective lens with this particular magnification power, 100 times. Okay, and the function of the oil immersion will be to increase the refraction index so that the image is clearer and looks nearer to the eyes. Okay, so you just fill in the blanks. And for the conclusion, the conclusion, we can say that the image seen under the microscope are bigger or larger than the objects. Okay, clear and also inverted. The higher the magnification, the smaller the field of view, or the narrower the field of view will become. And another conclusion is that the prepared slide of bacteria can be observed by using the all immersion techniques. Okay, so this is actually something that we will be doing if we get the chance to go to the lab next semester. Okay. Okay, and usually there should be some reference, okay, that you can include in your lab report. And so the most popular book that we usually refer will be this particular book, written by Campbell and friends. And the way we write the reference will be the name of the authors first, the name of the authors, and this is the way we write the name of the authors. Okay, maybe you can copy this down for future reference. Okay, normally we will write this same reference for our practical test later. You can also include the lab manual as your reference if you want. Okay, but at least you need to have one at least. And normally the students will choose the this particular book by Campbell as part of the reference. So first will be the name of the authors, and the way we write will be like this, the surname, nama family dulu, and then this will be the front names of the authors. Neil A. Campbell. So we write it this way: Campbell, comma, N. Dot A. Dot, comma. Then the second author pula. The second author, the third author, the fourth author, the fifth author, and the sixth author. Okay, author number 6. And then in bracket will be the year of publication. For example, for this particular 11th edition, it will be 2018 in brackets, in brackets. And then dot, the title of the book. Okay, the title of the book, Biology, a Global Approach. And this will be the edition, the 11th edition. And then you put the name of the publisher, Pearson Education Limited. Okay. Okay, and so after the reference, then there will be some question that we need to settle. Okay. So for questions 1, 2, 3, 4, 5, 6, 7. Okay, this will be the answers. Just check and make sure that you got all the answers correctly. Okay, number 1A. Number 1 is objective lens A, the shortest one. Objective lens 4 times. The same goes for question number 2, also objective lens A. Question number 3, also objective lens A. Question number 4, also objective lens A. And for question number 5, it will be objective lens D, the all immersion objective lens. For question number 6, it will be the objective lens A. For number 7 part 1, okay, it will be this objective lens B, and for 7 part 2 it will be objective lens D. Okay, now for part B. What do you use in order to clean the microscope lens? We use the lens tissue. Okay, the lens tissue. Okay, and applying the concept of inverted image under the microscope. So if the microorganism that you observe is moving to the right, so you need to move your slide the opposite direction, that is to the left, to the left. And if the specimen is moving to the top, then you move your slide nearer to you or towards you. Okay. Okay, then moving on to part C. Complete the following sentences. Okay, number 1, a microscope is called a compound microscope when it consists of more than one set of lenses. That will be the ocular lens and the objective lens. Okay, one set of ocular lens and objective lens. And C, part 2, condensation and the iris diaphragm will be useful to coordinate the light intensity. Okay, and so that will be the answers, okay, for this particular part of the lab report and the question part. So this is just a guide for you to do the lab report for your future experiments. Okay, so that's all for now. Okay, bye bye.